Hi, and in this video we're going to look at carrying out checks on data so that you can find errors or report things that might be suspicious in your data and take whatever action you care to take. The files for this video can be found in the folder DAT02. So let's work through this script and have a look at what all these checks are doing and see what all the rules are. So if we come down to the first line of code, which has got a check statement in it, we can see the first statement is a check statement, and what that's doing, it's checking the count of what appears in brackets is equal to 1. So what that's doing, it's looking at column 13 on the data, picking up codes 1, 2, 3 and 4 and checking that every respondent has got one answer. And if you only wanted to check that everybody had no answer or one answer, it'll be quite permissible to say 0 plus 1 or 0.1, and that would check that everybody had either no answer or one answer but not two answers, which wouldn't be possible with ASCII data, but of course it could be possible with binary data. So that's checking that there's an answer in 1 to 4. This is exactly the same as saying check count 13 colon 1, 2, 3, 4. It's just picking up all the codes individually, but it's the same as saying 1.4. This syntax is a little bit different from anything else probably you found in MRDCL. The colon here separates the column from the codes that you want to check. Now you can do the check the other way round. You can say if the count in that field 1.4 or 1, 2, 3, 4 is not 1, take some action. So a check statement stands up on its own, as it were. An if statement where you reverse the check, saying if a check or a count is not 1, afterwards you would need to take some action. And typically what you would do here, or certainly to get the same results, you could list out some columns. So you can choose which columns are listed. EL is a shorthand for edit list or EList, so EL and EList are the same thing. And that would list out the data in 12 and 13. Now the difference between that and the two examples above is that it allows you to choose what fields or columns you actually list out with the error. In the one above, this one here, it would only list out 13 because that's the only column mentioned in the check. Whereas here we're actually selecting what columns we list out, and so it would actually give the answer in 12. And if that's helpful to the person who is perhaps fixing these errors or inspecting these errors, listing out 12 and 13, this is a way of doing just that. Now the other thing that you can do here is that you can, rather than using edit list, you can just use the list statement. So this is the same as the one above, except we're using the word list, which can be abbreviated to L if you want to. And the only difference between an edit list and a list is that an edit list statement, and a check statement for that matter, will reject the record from the IDF. So it won't get passed to the IDF. Now, in a script where you're just checking data, that doesn't matter. But in a script where you're going on to run some tables, either from that IDF or as a table stage at the end of the data stage here, that would matter because it would exclude those records. They wouldn't get written to the IDF, and therefore your tables would be based on the records that didn't fail any of these checks or edit list checks. And that's one way actually of excluding records. So if you have a question that's a screener question where you want to exclude some records, that's a perfectly good way of getting rid of people by saying if they don't fulfill the criteria you want to go on and complete the rest of the survey, you could set that as a check statement or as an if edit list statement, and you could then exclude them so that they didn't get to the IDF and wouldn't get into your tables. Otherwise, though, a list and an edit list is the same thing. It's just putting the answers or the errors to a report. Now, the next check statement we're going to look at looks at data across a number of fields. So what this means is that we're checking 13 for any code whatsoever. So that's the same as saying colon 1 to 9 naught or colon 0 to 9. It means every code's being picked up. Likewise for column 14, we're picking up any code there. And finally on 15, we're just picking up the codes 1, 2 and 3. So that's checking that there's only one answer anywhere on 13, 14 or 15, codes 1 through to 3. The next check in our list here is what we call a two-way check, and you can see it's got an equal sign in the middle here. And what this means that it must be true on both sides of the equation, perhaps is a way of thinking of it. So let's ignore this message in quotes here for just a minute. We'll come back to that. But what this is saying, that 13 and 1 should equal count 14 codes 1 to 6, a count of 1. So what that's saying is that either this must be true, in other words, they must be 13 and 1, and they must be a count 1 between codes 1 to 6 on 14, or they mustn't be 13 and 1, and they mustn't have a count 1 in codes 1 to 6. So either both sides of that equation should be true, or both sides should be false. So that's why you could think of it as an equation. The text here in single quotes is just an extra error message where perhaps you can put a message to somebody who's got to look at this data and perhaps something that helps them solve it or gives them some clue as to what the problem is here. So that's an equals check. Now we've got some checks on a whole column. So this is just checking that 13 is single, so it must have one answer. But it can't have more than one answer and it can't be blank. The next one is checking that it's multi, and you can have the negative of that. You can check it's not multi, you can check blank, and you can check not blank. So all of those are quite acceptable commands. Now we get to some slightly more complex checks that you might want to run. You can also use variables in your check statement. So you, for example, could have a question 1 which picked up spontaneous awareness, and then any other answers, all the answers, it should be in prompted awareness at question 2. So if they picked brands 1 and 2 at question 1, you'd expect them to have brands 1 and 2 at question 2. So having defined those variables, we could define a variable called check, which says that anybody who's in Q1 and not in Q2 should result in a variable called check. And if that check is not blank, we want to list that out and give the data in 15 and 16 so that we can inspect that and see why they're not in prompted awareness when they've already said they're in spontaneous awareness. So that's a check that you can perform on a variable, having done some transformations of data inside a variable. The topic of using ands and ors and nots is actually covered separately and fully in a separate video. Down here we're getting another check where we're checking, for example, that if an answer is in both 15 and 16, it's in both spontaneous and prompted. So this time it's where you'd expect answers to be in both. It will come through as an error in check. All right, now we move on to doing something with numbers. So here we're defining a variable that's adding up 4 number fields together. They could be variables rather than just blocks of columns. So it's adding together the data into a variable called total that's in fields 11 to 12, 13 to 14, 15 to 16, and 17 to 18. Having got that total, we're now checking that the sum is 100. If we just used a check statement there, if we just said check total /100, the only message we would get out would be that the total was 95, for example. We wouldn't be able to see the sum or the individual figures that made that total. So here we can actually list out the data. It might be a good idea to list out total as well. So if there was an error, we could see that the figures that made up that 95, if that's what the total was, were made up of 25, 25, 25, and 20, for example. Here we're doing some more transformations of data. We're trying to check that the most often brand is in all brands as well. So that's another similar check that the most often brand, which is a 2-digit code, is replicated amongst binary codes in the relevant columns here. Here we're doing a filtered check. That's perfectly acceptable. So we're saying that perhaps if none of these is 14 code 9, we might want to check that all the other codes are blank. So let's say this question is picking up 18 brands, and then none of these is the 19th code. We could check that if it's got none of these here, we can check that all the other codes are blank or have a count of 0. Here we can do some checking on rank orders. So we want to check here that where some brands are ranked in order or some statements are ranked in order, we've got a loop within a loop here, which is producing some fairly complex code, but it's basically checking that if a rank order appears in one of the fields, it doesn't come up again. So we don't want somebody who ranks this as 1, 2, 2, 2, 4. That would be wrong. So that's doing some checks to make sure that the same rank order doesn't appear in more than one place. Moving down to here, we've got to check things in a sensible order. So if the rank order is 2, there must be a rank 1. So a similar sort of application. And that looks a bit easier to look at if we look at the code at the bottom that it's producing. There we are, we're just checking down here effectively that the code at 12 doesn't appear anywhere else, the code at 13 doesn't appear anywhere else, and so on. So that's doing some quite clever checks there on that data. Now when you run your report, let's run it, you'll get your report in a report.txt file. So this is called run8, and the report comes out in run8 report.txt, and all the errors are dropped out as you would expect. I think it's a good exercise to actually run this and just work through the data file that's provided and just have a look and just check that you understand where all these errors have come from. And at the bottom here you get a summary of all of the errors. Now there's only one record in this particular data file, but it summarizes the ones that have got no occurrences, one occurrence, and so on, so that you can perhaps look at some of the more suspicious errors, or ones that are coming up in large numbers where you've got larger numbers of records that you're processing. So that completes this introduction to running checks on your data. Hope you found it useful, and thank you.